The following slides will be using Cuisenaire rods that are sitting on paper that's marked in various places. This is a three-dimensional model, even though we're really only considering the length of these rods. So it looks like 0 and 1 are not at the ends of these rods, but we're looking at a picture of these rods from above. So they really do have the lengths that are marked on the paper. So consider this length to be 1. So we have one hole with benchmarks of 0, 1/2, and 1 marked. And then the hole is partitioned into 8 equal-sized pieces, and now 6 equal-sized pieces. So we have eighths and sixths. So now consider the comparison of 7/8 and 5/6 with this model. Note that each of these fractions is one unit fraction away from the whole, seeing the residuals as the pieces missing to make the whole. Since 5/6 is missing a bigger piece, sixths are bigger than eighths, because eighths take more equal-sized pieces to make the whole, so they must be smaller. It is farther away, or farther to the left, from the whole, so therefore 5/6 is smaller. Take a minute to consider that again, where you're considering the residual rather than how many of the pieces that it takes to make a whole. You're considering also the size of the piece that it takes to make the whole. To articulate this strategy again, with this example, each of these fractions is one unit away from the whole, seeing the residuals as the pieces missing to make a whole. Since 5/6 is missing a bigger piece, because 6 are bigger than eighths, because eighths take more equal-sized pieces to make the whole, so eighths must be smaller. Therefore, 5/6 is farther away, or farther to the left on the number line from the whole. So 5/6 is the fraction with the lesser value. We could also use the number line to represent this. Notice that regardless of where we start with either 5/6 or 7/8, we know that both of those numbers are less than 1, so they go to the left of the number line. So if we start with 5/6 and say 5/6 is to the left of 1 on the number line, and we'll say, by how much? How much do we have to go back from 1 to get to 5/6? Which is 1/6. And now we say 7/8 is also less than 1, but is it less than 5/6 or greater than 5/6? So 7/8 is less than 1 by 1/8, and we know 1/8 is less than 1/6. Therefore 7/8 is closer to 1 than 5/6 is. So when asked to compare 5/6 and 7/8, we're using 1 as our benchmark and looking at how much does it take to get from each of those fractions up to the benchmark. So it takes a sixth to get from 5/6 to 1, and it takes an eighth, or it takes only an eighth to get from 7/8 to 1. Consider the same type model, but now we're going to look at 9/8 versus 7/6. So just by looking at the model, you can tell that 9/8 is going to be 1/8 more than 1, and 7/6 is a sixth more than 1. So we're considering that residual, we're considering that extra amount greater than 1. So 9/8 is only an eighth greater than 1, whereas 7/6 is a sixth, which is greater than an eighth, a sixth away from 1. Therefore 7/6 is greater than 9/8. So again, we can use the number line, and it doesn't matter whether we start with 7/6 or 9/8. We know both of those fractions are greater than 1. So we place 1 on the number line greater than 1, and we identify how much more than 1 is that number. So let's say we start with 9/8. 9/8 is 1/8 away from 1, 1/8 greater than 1. So then 7/6. We know 7/6 is 1/6 greater than 1. So the question now is 1/6 greater than or less than 1/8? In other words, is 7/6 closer to 1 or further away from 1 than 9/8 is? And because a sixth is greater than an eighth, that means 7/6 is further away from 1 than 9/8 was. So notice that when using residual reasoning, the fraction that has the biggest pieces isn't always the greater fraction. It depends on which side of the benchmark you're on. Notice that we could also use 1/2 as our benchmark, because we know that 4/8 is equivalent to 1/2, and 3/6 is also equivalent to 1/2. So now if we compare 3/8 and 2/6, we can say how far away from a different benchmark, how far away from 1/2 is 3/8 and 2/6. So notice that 3/8 is 1/8 less than 1/2, and that 2/6 is 1/6 less than 1/2. So we're indirectly comparing 1/8 and 1/6 to see which of our original fractions is closer to the benchmark of 1/2. So you can see from this model that 3/8 is greater than 2/6 because 3/8 is closer to 1/2 because 1/8 is less than 1/6. We could also use the number line very similarly as we did before, but 1/2 will be our benchmark, and say we could place 3/8 or 2/6 on the number line and see how far either of those is from 1/2. So if we start with 2/6, place that on the number line, we know that 2/6 is 1/6 less than 1/2, and now we say 3/8 is an eighth less than 1/2. Is that eighth less than or greater than 1/6? We know that 1/8 is less than 1/6, so that puts 3/8 closer to 1/2 than 2/6 is. So consider this model. What fractions are being compared here? It looks like 5/8 and 4/6. So consider the question, why wouldn't the other benchmark, the benchmark of 1, work for residual reasoning? You'll probably come to the conclusion after a little thought that we can't use residual reasoning unless we're comparing the same number of pieces that the fraction is away from our benchmark. So 5/8 is 3/8 away from 1, and 4/6 is 2/6 away from 1. So if we were using 1 as our benchmark, we would be comparing 3/8 and 2/6, and it's not a comparison we really want to make. So instead, if we use the benchmark of 1/2, we can see that 5/8 is 1/8 greater than 1/2, and 4/6 is 1/6 greater than 1/2. And from what we know about eighths and sixths, we can see that 4/6 is greater than 1/2 by more than 5/8 is. So therefore 4/6 is greater than 5/8. So again, look at this model and think about what fractions are being compared, and then which benchmark is best to use and why. This problem is having us compare 6/8 and 4/6. If we use the benchmark of 1/2, we'll be comparing indirectly these residuals of 2/8 versus 1/6, which is not really a fair comparison. 2 of one piece versus 1 of the other. Instead, if we consider the benchmark of 1, then both fractions have a residual of 2 pieces. 6/8 is 2/8 away from 1, and 4/6 is 2/6 away from 1. So now we're comparing 2/8 versus 2/6. And because of what we know about eighths and sixths, we know that 2/8 is less than 2/6. Therefore, 6/8 is closer to 1 than 4/6. And again, we can use the number line very similarly to show, in this case, we have 2 pieces. Our residual is 2 pieces versus the 1 piece we had before, but it's the same thinking. If we put one of the numbers on the number line in the correct orientation relative to our benchmark, like if we start with 6/8, 6/8 is less than 1 by 2/8, and then we ask the question, well, where is 4/6 relative to 6/8? Is it further away from 1 than the 2/8 was, or is it closer to 1? And because 2/6 is greater than 2/8, that means 4/6 is further away to the left, less than 1 than 6/8 was. So 4/6 is less than 6/8. Same conclusion. So here's another problem. What fractions are being compared here? What benchmark is the best to use? And why wouldn't the other benchmark work for residual reasoning? So here we're comparing 6/8 and 5/6. Notice that both are less than 1, and if you ask the question of by how much, 6/8 is 2 pieces, 2 unit fractions less than 1, whereas 5/6 is 1 unit fraction less than 1. So 1 is not going to be our best benchmark because we'd be comparing 2 unit fractions to 1 unit fraction. If we use the benchmark of 1/2, we're comparing the residual of 2 unit fractions to 2 unit fractions. So 6/8 is 2/8 greater than 1/2, and 5/6 is 2/6 greater than 1/2. Well, 2/6 is greater than 2/8. Therefore, 5/6 is further to the right of 1/2 than 6/8 is. So 5/6 is greater than 6/8. So what can we say about residual reasoning? Students need to recognize that both fractions are the same number of unit fractions less than a benchmark, or the same number of unit fractions greater than a benchmark. We have to decide which of those benchmarks it is, but both fractions need to be the same number of unit fractions less than or the same number greater than a particular benchmark. The student has to know which fraction has the greater sized pieces. The fraction that has the greater sized pieces will be farther from the benchmark. You have to attend to which side of the benchmark the residuals are on to decide which is the larger fraction. If the fraction is further to the left of the benchmark than another fraction, that means that first fraction is less than the second fraction. If a fraction is further to the right of a benchmark than a second fraction, then the first fraction is greater than the second fraction. And then we must show the relationship on a number line to see the connections. Residual reasoners recognize that if both fractions are the same number of pieces from the benchmark, all they need to do is consider the size of the pieces.